today's work and our next like 4 days of work, it's all going to be dealing with exponents. And I just wanted you guys to hear from someone that most students in 096 find this section of the course to be the most difficult. Okay, so, and it's because there's going to be an ever-growing list of rules, right? Things that you need to remember how to use them. It just gets longer and longer each class. And there are a bunch of things that are not rules that you cannot do, and you have to remember what those are too, because they look like they could be totally reasonable things to do. Like, so you have to remember what you're allowed to do, what you're not allowed to do, and the list just gets longer and longer and longer. So one thing I handed out to you today, it should be sitting on your table somewhere, is this key formulas for exponents, radicals, and rational exponents. Keep this handy, like when you're doing your homework. Maybe bring it as one side of your page of notes to the next quest, right? And refer to it whenever you have a question, okay? Whenever you're not sure, check it. And also remember that you can always come up with a simple, easy example if you can't remember which rule you're supposed to use. Do I add the exponents? Do I multiply them? We'll practice making up easy problems that will remind you which rule applies, okay? All right, so let's start today's lesson. Okay, so we're going to talk about negative exponents, scientific notation, and roots, like square roots. All right, so let's look at a pattern and try to discover what we taught. I told you this last class, but I didn't give you a good reason, right? Anything, when you raise it to the 0 power, the answer is 1. Okay. So let's look at the pattern over on the right-hand side of this thing. 3 to the 4th, what does that mean? By 3 times 3 times 3 times 3, which turns out to be 81. Okay, 3 cubed, 3 times 3 times 3 is 27. 3 squared is 3 times 3, which is 9. 3 to the 1st is just 1 3, which is 3. All right, now look at the pattern. 81 to 27. How do you get from 81 to 27? How are those numbers related? Divide by 3. If you divide 81 by 3, you get 27. What do you get if you divide 27 by 3? 9. What do you get if you divide 9 by 3? 3. Okay, so now we can no longer use the definition to figure out what 3 to the 0 means because it doesn't make any sense, right? But if I follow this pattern of dividing by 3, 81 divided by 3 gave me 27, divided by 3 is 9, divided by 3 is 3. What is 3 divided by 3? 1, right? So you just divide by 3. And then we could even keep going following the same pattern to define negative exponents. Okay, so what is 1 divided by 3? 1 over 3. And that's actually 1 over 3 to the 1st. What is 1 over 3 divided by 3? 1 over 9, which is the same thing as 1 over 3 squared. So it was 3 to the negative 2, and it became 1 over 3 to the positive 2. What is 1 over 9 divided by 3? 1 over 27, which is the same thing as 1 over 3 cubed. So if I follow that pattern, we might guess that 3 to the negative 4 would be 1 over 3 to the positive 4, 1 over 81. So that's the pattern. That's the reason why we can define raising something to the 0 and raising something to a negative exponent, even though it doesn't make any sense in terms of repeated multiplication. If we follow this pattern, we can still apply the rules. We can still come up with an answer. So it turns out if you want to do something to a negative exponent, that's the same thing as doing 1 over that thing to the positive exponent. Okay, so that's the first way of thinking of that rule. Or in reverse, if you have 1 over something to a negative exponent, you can bring it up into the numerator and make the exponent positive. Okay, so a short, useful shortcut, a useful shortcut for negative exponents is that negative exponents indicate movement. If you see a negative exponent, you have to move that term to the other spot of the fraction. Yep. No, don't let him in. Go sit down. If you see a negative exponent in a numerator, you can make it positive and move it to the denominator. If you see a negative exponent in a denominator, you can make it positive and move it to the numerator. So I want to rewrite 10r to the negative 9 times d to the negative 7 over 25r to the negative 5 times d cubed, so that there are no negative exponents. So I'm going to identify the terms that have negative exponents and move them. Just move them to where the opposite location and make them positive. So the 10 is going to stay the same. Okay. R to the negative 9 is going to move, right? It's going to move to the denominator and become R to the 9th. D to the negative 7, that's going to move to the denominator and become D to the positive 7. 25 stays in the denominator. R to the negative 5, it's got a negative exponent, so it's going to move to the numerator and become positive.
Right. You got D to the negative 7, you got D to the third. Is three of those going to cancel?
Oh yeah, you could cancel. I like to write everything with positive exponents before I cancel. This d cubed, it's already a positive exponent, so I don't have to move it. So just leave it in the denominator. And then once everything is just positive exponents, then I cancel. You could cancel beforehand if you want, or apply the subtraction rules that we did last class. Okay, so the next thing I'm going to do is simplify, do some canceling. 10 over 25, what does that reduce to?
2/5.
2/5, yeah, you would say, okay, 5 goes into both of those numbers, goes into 10 twice, and it goes into 25 5 times. And then r to the 5th over r to the 9th, how is that going to reduce?
The R and the 5th are going to cancel out.
Yeah, and then we're going to have 4 r's left. We're going to have an r to the 4th. Is it going to live in the numerator or the denominator? The denominator, yeah. Because think about what that means. That means r times r times r times r times r on top. And on the bottom, you've got r times 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 r. And 5 of them will cancel, and you'll have 4 left on the bottom. So I'm going to have my fraction, I've got 2/5. I'm going to have an r to the 4th on the bottom. And then d to the 7th times d cubed, what is that? D to the 10th, right? Where the rule was when you're multiplying like bases, you can add the exponents. 7 and 3 makes 10. So I've got d to the 10th on the bottom. Any questions there? Okay. Okay. Scientific notation allows us to easily work with very large or very small numbers. We write numbers in this format by changing a number that's really big or really small. We make it a number between 1 and 10, and then we multiply by a power of 10, because multiplying by 10 moves a decimal point. So for example, U.S. national debt in 2012 was approximately, let's see, thousands, millions, billions, trillion. $15,460 billion. If I wanted to write this number using scientific notation, I need to change this to a number between 1 and 10. Where should I put the decimal point in this number to make a number between 1 and 10? Right after the 1. So I would write this as 1.546. And then I have to multiply by 10 to some power. Right? I have to figure out what power to put there. Okay, so if I have my decimal point right here, every time I multiply by a power of 10, the decimal point would move 1 to the right, right? So I have to count how many places to figure out how many times I want to multiply by 10. So I'm going to multiply by 10 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times, 12 times, 13 times. So I have to multiply times 10, times 10, times 10, times 10, times 10, times 10, 13 times, right? And repeated multiplication is an exponent. So I do 10 to the 13th. Okay. So 1.546 times 10 to the 13th. Okay, the diameter of a typical bacterium is about, see, I want to say this number right. That's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 2 10 millionths, 2 10 millionths of a meter. Okay. I want to rewrite that number in scientific notation. Where should I put the decimal point in that number to make a number between 1 and 10? After the 2. Yeah, so this is going to be 2 times 10, and then I have to, if I put the decimal point there, I'm going to have to move it to the left to get it back. How many places will I move it? 1, 2, 3, 4, 5, 6, 7 places. Because I want to move left, I have to do a negative exponent. So this is going to be to the negative 7. Any questions? Okay, that's it for the demo. You have 3 fairly long activities, so get going.